All right, so this is the math portion of our project-based learning, and in this math section, we're going to be looking at data analysis. And data analysis has three main parts that we're going to look at. The first one is interpreting data. The next will be collecting data, and the last one will be presenting data. And as you can see from the picture up here, they kind of all go together in a circular fashion. You'll start off by maybe interpreting some data. If that doesn't really fit what you're looking for as far as your report or the data that it gives you, you might have to then go out and yourself go out and collect some data, create a new survey, maybe a new study, new research part to collect data in hopes that you find something that will support whatever you're writing about. And then once you collect that data, you're going to put it together in a meaningful way that will show what you were looking for and hopefully add to your report and presentation. And from there, either you'll do the interpretation of your own data and how that helps you, and then also your readers will be interpreting that data, and hopefully, again, that will help strengthen the points that you're making in there. So looking at the first section more closely, interpreting data. When looking at data tables and graphs, the most important resource is your own ability to analyze the data, notice trends, and see how different factors affect the data. There are some things you can kind of calculate and numbers you can do, but most of it is going to be looking at it and thinking, okay, what are the trends of this data? What factors come into play here that will determine what the data does? And ultimately, when you use this in your research or in your report, you have to find data that helps support whatever you're writing about. Not all data that you find is going to be meaningful to whatever you're talking about. Some data may prove the opposite of what you're doing. Some data will support your thing, and some may have no relevance at all. So you have to not only just notice what's going on with the data, but also put it into some context as to how it relates to what you're working on. So here's a couple of examples of some data. On the top left, we have a bar and line graph. And this one's looking at the population in California and then how the water use is affected. And if you look on this one, you see the population's increasing, but the water usage doesn't always increase. So you'd say, initially you might think, the higher the population is, the more water usage that goes on, but this graph maybe doesn't show that. So if in your report you say population is the biggest factor, this may not be something you want to use because it doesn't really support your claim. Other data examples that you'll come across might just be a straight table, and you'll have to look at all those numbers and kind of see what they're doing. Are they increasing, decreasing, staying the same? And then how that and what factors go into each of those different ones. And then on the bottom left, you have a little combination of both. You got a picture that kind of shows water usage throughout California. So you might say, the main areas in California that we need to focus on are the Central Valley, as you can see from this graph or this table and chart. All right, second section, collecting data. During our work with the prototype, you will be collecting data on your specific prototype and using that to maybe influence how you design it, changes you make, modifications, but then also in the end, you'll be using that to show how effective your prototype was. Some things to remember when collecting data: record everything. Even if you don't think you'll need it, it's better to have it and not use it than to later go, I should have wrote that down or something. And always have multiple places. If you're in a group, have 2 or 3 members write it down. Keep the file. email it to yourself. That way, if something happens, your computer crashes, you lose a flash drive, there's another place that you can get that data without having to redo everything. When making tables or charts, label everything clearly. Make sure that when you go back and look at that data, you go, oh, I know what this is. If you just have a table full of numbers and nothing's labeled, you're going to go, well, this doesn't do me any good because I don't know what it is. Also, while you're collecting data, you need to be thinking about the data that you're collecting. You can't just be mindlessly writing down these numbers. So check the data that as you're taking to ensure that the quality is good. Maybe with your prototype, something that you're sensing, there's something wrong there, and you're getting values that are way too high or way too low. And if you are checking your data, you can catch those things early, go back and fix them, as opposed to trying to do it days or weeks later. Also, while you're looking at the data, start noticing trends and begin to analyze it. And just anytime you're thinking about it, it'll help later on down the road. So we're going to be using Excel in this project with data collection. So on the top left, you can see kind of example of a bunch of data and putting it nice and neat in columns and stuff. If you notice on the top of each column, it says, what those numbers mean. And then on the bottom left picture, you see someone taking it by hand as well. Great way to just kind of double up and ensure that you have backup given, any unforeseen, events that happen, you still have that data. On the bottom right, you can see that this person has their data on the left, and then they have a chart that they're plotting the data as they go along, so they can see those trends. They can start thinking about what's going on while they're taking the data. And again, that may not be what the final graph is going to look like. It's just kind of a simple thing to do so they can check themselves as they're taking the data. All right, last, presenting data. So once we have all our data, we started making tables and charts and graphs and stuff. We're going to need to present that in our final report and in our presentation. And we want to make sure that everything is nice and clean. Everything's labeled clearly. Whatever you're trying to get across, you want to make sure that that's easily noticeable to whoever's reading it or looking at it. Remember, these people that are reading it haven't done all the research that you have. So you need to get the information that you've learned and kind of present it in kind of quick bullet points, really easy to read. When doing graphs, add trend lines to help with your analysis. Trend lines are a great way to see what the data is doing kind of at a quick glance. And then when you do all your data collection and presenting and analysis and stuff, you need to, again, ask yourself, will this support my research or the issue that I'm writing about? And it may not. You may, after you get a bunch of data and you look at it and you go, this isn't working. So then you go back and you change something to your prototype. You create a different procedure about looking at something. And that's kind of what it's all about, is finding data that helps you and that will make meaning towards what you're doing. So when you present the data, there's different types of graph you can use. There's bar graphs, pie charts, scatter plots, line graphs, and all these are used for different types of things. Bar graphs are great for discrete variables. So like on the bar graph example here, we got just something kind of simple with vegetables and how many. So it's great for counting things, where like how many onions we have doesn't really affect how many tomatoes we have. It's just independent kind of things that we're just counting. If we look at a pie chart, pie charts are great for seeing how each little piece relates to as a whole section. So you can see each of these little wedges has a percentage on it, so you can see, okay, this red section is 19% of my whole. Scatter plots are probably what we're mostly going to be doing with our data